Hi, this is Steve. Welcome to our series. In this segment, we're going to look at the heating parameters. So that is mode 4. When you press mode 4, it comes up on heating, and that is for the Wi-Fi and the zoning models. For the base model, it's a little bit different, but this would be for the Wi-Fi and the zoning models. So when we go into, press the mode button to get to mode 4, press enter. Now we're into parameter number 1. So parameter 1 is the minimum pump speed. The default is 45%. We can go in and adjust this right down to 35 and then right up to 100% if we want. So whatever that minimum pump speed that we need, and that's based on the heat source that we're using, the resistance of the heat exchanger of the heat source, the amount of elbows and the length of piping between and components in that line. So it can all vary. So we can increase or decrease the minimum pump speed to ensure that when it comes on at a minimum, that it's going to fire, for example, the tankless water heater. This will have to be adjusted on site as per your system. So each is going to be unique, so no problem there. So let's just assume 60% works. Enter, and it's set. Minimum blower speed would be the same thing, so that's parameter number 2. It's default set at 10%, but you can go all the way up to 100% if you want. So this is again where the minimum blower speed to ensure that you're getting air through the system. And these are all for heating. These are all heating parameters. Number 3 we're not going to use, so it skips to number 4. Number 4 would be the maximum pump speed. So basically we have default set the maximum at 80%. You can actually increase it up to 100, but you're not going to see much more flow rate. It will increase the head pressure a bit, but head pressure is usually exponential. So even pushing it from 80 to 100 is really not going to give you much more flow rate. It'll provide more power to the motor, but likely not much more in the way of flow. So we've kind of maxed it out as default at 80, but if you feel you want to go higher and try it, by all means you can do that. Parameter number 5 is the maximum blower speed. So again, we want to use this to ensure that when we're running at highest capacity, we're not oversupplying CFM for the ducting that is available. So we can run it up. So the default is 60, but we can run it right up to, let's run it up. We can run it right up to 100% and start there and bring it on. Bring on the blower with a call for heat. And if that is too much, then we can reduce down from there. Okay. And where do we reduce down to? Well, reduce it down to a point where you've got good delivery at all the registers, where you're comfortable that the sound is where the homeowner is comfortable with, that it's not too loud, it's quiet as possible, and that would be the number that you could use. And as long as that matches with your duct design and BTU design, then it's good to go. So all to say that we're able to adjust the maximum blower speed in 1% increments, right up to 100%, and then right down to as low as 10%. So again, as we saw when we were setting the maximum BTUs in the general parameters, if we want to use, so this unit may be capable of running 1400 CFM, but maybe we only need half of that. So we could easily come in, run it at half, 50%, and then the unit would run at half the capacity of the BTU of this regular CFM. So this is how we enable you to really fine-tune the adjustment on the iFLOW to really just deliver exactly what you need into the home. But let's just set that. So our default was 60, so let's go back up to 60 in default. And then we'll press enter to store that value, and that's parameter number 5. Parameter number 6 is blower on delay time. So we want to make sure, so the iFLOW is fairly unique in that it will wait until it gets hot water at the hydronic coil before it starts the blower. So on a call for heat, it's going to monitor the incoming water temperature, and if the temperature is 70 degrees, 60 degrees, it is not going to fire the blower because, or bring on the blower because it doesn't want to blow cold air into the home. So it's going to wait until it sees at least 90-degree temperatures coming into the controller or into the heat exchanger to then bring on the blower. This blower on delay time is how long do we wait for that water to come to the unit before we throw an error code and tell you, hey, there's this problem with your heat source perhaps, or a problem with the pump perhaps. All to say we're not getting hot water delivered to the coil, and as a result we're not going to turn on the blower. We defaulted to 25 minutes because there are some situations, for example, if you're running with a boiler and an indirect tank and that has domestic priority, then you could be running the domestic hot water side for a fairly long time, which means even though during that domestic priority call there is a call for heating, we won't be able to turn on the unit until that domestic priority call is done, unless we're able to pull water from the primary loop, for example, depending on how it's plumbed in. But nonetheless, if you're expecting, if you're very close proximity to the tankless water heater, if that's your heat source, you could run this down to perhaps 30 seconds or 2 minutes or 1 minute, and that would normally be more than enough to get the hot water at temperature into the coil. But in the cases where you're running with a boiler or you have some domestic priority on your combi boiler, for example, then it may take a little longer, and you can adjust that before we throw an error code. So that's what parameter number 6 is. Parameter number 7, blower off delay time. So once a call for heat is completed, to maximize efficiency, we know that there's going to be some residual heat left in the hydronic coil. So what we do is we keep the blower running to deliver all of that heat into the home instead of just leaving it in the hydronic coil. We can adjust that blower off delay time from 0 to 180 seconds or 3 minutes. So our default is 1.5 minutes. But we can run it as high as 3 minutes, which would be more than enough to deliver that heat into the home, maximizing your efficiency. And following on parameter 7, we have parameter 8, which is our post-purge function. So when our heat source shuts down, there may be some residual heat left in the heat exchanger of the heat source. And as such, we want to try and recover as much of that heat as we can, bring it into the air handler, and then move that air across the heat exchanger inside the iFLOW and deliver it into the home. So this post-purge function is parameter number 8, and we can set it to on or off. The default is on, so it will always try to recover that, and it's going to recover it based on the pump cycle time that we set in the general parameters section. It's going to use that same, if we set a pulse signal, for example, or a pulse on-off sequence, then it will use that pulse sequence when this post-purge function is set to on. But again, these two, so 7 and 8, are used together. The blower off delay time in combination with the post-purge function to again try to extract all of the residual heat out of the heat source, bring it into the iFLOW, and then deliver it into the house. Parameters 9 and 10 are not used at this present time. Let's go and so as you see, it skips right over from 8 right over to 12. Okay, 12 is the heat source type. So here our default, so the heat source type is 2. We have hot water only, so that would be basically we're running with a tankless water heater or a boiler, or a combi boiler, or a tank type water heater, whatever the case may be. So we will start the pump to bring that water to the hydronic coil and deliver it through. There are cases, however, where we can run with a heat pump as well. So we've got hot water and we're running with a heat pump. We have to tell the unit which setup we have. Is it only water, which would be 0, which is our default, or do we have a heat pump? If we're running hot water and a heat pump, then we want to set this heat source type to 1. So here on my controller, I've got it set to hybrid mode, which is the hot water and heat pump. Let's set it back to default. So press 1 to enter, it flashes, bring it down to 0, enter to save. So now we're back to our default, which is hot water only. When you have a heat pump, you must also remember you need the DH evaporator sensor temperature connected to the suction line near the evaporator to be able to detect the reversing valve operation when you've got a heat pump. So all to say that, and if you don't have that, your heat pump won't run. So hybrid mode won't run properly. So even if you have the heat pump but you don't have the DH evaporator sensor temperature installed yet, then you might want to run in hot water mode until you get those proper components connected and wired in. So you see that I switched to jumped up to 18. So 18 goes into the zoning because this is a 2-zone board. But the reason I skipped 14, 15, 16, and 17 was because we told it we weren't running in with a heat pump. But let's go back in. Let's go back to 12. We'll tell it now that we are running in heat pump mode. And now we will press that, and all of a sudden 13 appears. So what's parameter 13? Parameter 13 is the outdoor temperature that we want to run the heat pump until. So for example, we look at the performance of the heat pump and we say that, okay, down to maybe it's 0 degrees Celsius or 32 Fahrenheit, down to that point the heat pump runs fairly well, fairly efficiently, but below that it starts to drop both in capacity delivery and capability. So at that point maybe we want to switch over to the water-based system. So we'll bring on the tankless or bring on the boiler or the combi boiler, whatever we have as our water heating source. So what we do in parameter 13 is we set the outdoor temperature that we want to switch over from heat pump to water-based. And that can range from -22 to 41 Fahrenheit. The default is freezing point, so 32 Fahrenheit or 0 Celsius. And on the Celsius scale, it can run from -30 to 5 degrees Celsius, depending on the heat pump that you're using. So this is where we set our crossover point or our balance point, and we will do that automatically. So if in this case, if we're using the default at 32, if the outdoor temperature is 35 or 40 degrees and there's a call for heat, we will bring on the heat pump to do the heating. If the temperature is below 32, then we will bring on the pump to bring the water into the hydronic coil to deliver the heating, and we will not trigger on the boiler, or sorry, the heat pump. So we have the choice of doing either. that is what this parameter 13 does. It sets the switchover point between heat pump and water-based heating. 14. Okay, in many jurisdictions there are peak energy times during the day. So for example, it could be 4 p.m. to 9 p.m. It could be in the morning. It could be midday. It really depends on the jurisdiction. With the iFLOW controller, we've enabled 2 peak periods. So when you set your peak period rate, we can avoid running the heat pump during that period. So for example, if every afternoon from 2 to 6 p.m. you have peak electricity rates, then we can tell the heat pump, hey, don't run during that peak period, run the water during that period. So we give you 2 sections. So basically we tell what time do you want to turn it on in parameter 14, and then in parameter 15, what time do you want to turn that off for period 1. And then we have a second period as well. So the start of period 2 and then the end of period 2. And those would be the peak rate period 2, peak rate period 1, and then we will not run the heat pump during those 2 periods. And then we'll get into parameter 18. Parameter 18 is the zone 1 blower speed. And this is the speed that we will bring on. We'll bring on the blower when zone 1 calls for heating. It can be a function of the it's a function of the total blower speed. So on a 2-zone system, it will typically default to 50% because you've got 2 zones, so we'll assume zone 1 needs 50, zone 2 needs 50. But then you can adjust it from there. So for example, 18 is the zone 1 blower speed. So let's say zone 1 is only 1/3 and zone 2 will be 2/3. So we want to bring zone 1 to 33%, so we'll press that. We'll bring the value down to 33%, press enter. So that is now set. So when we get a call for heating on zone 1, the blower will operate at 33% capacity. Zone 2, again, if we have a 2-zone system, now we want to run this up to 66%. So then we'll increase this to 66. So now we have zone 1 set at 33, zone 2 set at 66 for a total of 100%. You can divide these based on CFM rates per zone and using the maximum blower capacity as your guide. Or you can do it based on your heat load. If you have a heat load that looks at zone 1 and zone 2, and you can take the total heat load and then divide zone 1 heat load by the total to get a ratio, a percentage for zone 1, and then a percentage for zone 2, and then you can set accordingly that percentage into the blower speeds as well. If you're looking for the blower speeds, they are included in some of the documentation we have online, or reach out to us and we can provide those maximum CFMs. They are indicated in the manual and also in the brochure, on the back page of the brochure. So in this case, we only have, this is a 2-zone system, so it's only going to let me set 2 zones. So if I go up to any additional parameters, it locks me out because there are none for the 2-zone. But if I have a 4-zone system, then I'm going to be able to do the same for zone 3 and zone 4. And you see that on the 4-zone system, each of the zones would default at 25%, which makes sense. Now, if I set in my general parameters, if you recall, we were able to set the zone 1, zone 2, zone 3, zone 4. What system do I have? If I set to 3-zone, then this would be divided into 33, 33, 33. just as a default, and it would not allow you to, it would not give you a zone 4 control. So we automatically tailor the parameters that you will see to your previous answers based on the general parameters set up. And that's it for parameter or mode number 4, all of the heating parameters. Thank you.